So, increasing, decreasing, constant. Let's start there. We're going to look at these graphs now. And as you see, you have graphs. I gave you some graphs, right? And on those graphs, here's what you're doing when you're talking about increasing, decreasing, and constant. When you're talking about, you're looking at intervals. And on the intervals, an increasing function has a positive slope. And a decreasing function has a negative slope. What do you think a constant function has?
Same slope.
Good. So we call that zero slope. So if your function is increasing on a particular interval, it has positive slope. If it's decreasing on an interval, it has negative slope. And if it's constant on an interval, it has zero slope. How do we find slope again? Good. So the slope between 2 points is, we call it m. M is equal to y2 minus y1 over x2 minus x1, right? And what we're going to do is this. We're going to use the same form. We're going to manipulate it a little bit differently, though. So slope is just, you have 2 points. You have a point here. We'll call this point A. We'll call the x value for that point A. All right? You have a point here. We'll call this point, the x value for this point will be B. Let's actually find the slope of this line. The x values are A and B. Does everybody understand that? If this is A, then you can write this point as A, f of A. Just like if it were x, you would write it as x, f of x, right? Yes? What does f of A really stand for, though? Y. That's just the y value. Do you understand that? So really you still have x and y. You just call it, instead of calling it x1, y1, we're calling it A and f of A, right? And then you can write B as, the x coordinate is B, the y coordinate is f of B. Using this form, using this notation, how would you find the slope of this line then, or of that segment? What would you do? How do you find the slope of any line still?
F of B minus F of B.
Good. Thank you, Ethan. So it's f of B minus f of A. Y2, right? Minus y1 over, what goes at the bottom? B minus A. X2 minus x1. And this is important now because when we start talking mathematically about increasing, decreasing, and constant, what you're going to look at is, you're looking at your y values, right? Does everybody understand that? If a function is increasing, well, what has to be true about the y values? Well, if a function is increasing, then when a function is increasing, f of A is always going to be less than f of B. What does that mean? What does f of A stand for again? Not the x, but what does that stand for again? What does f of A stand for? The first y value, right? If a function is increasing, look at this graph. The y value sits where? Below, the first y value sits below the second y value. That's what this says. Does everybody understand that? If it's decreasing, what does that mean? F of A is now what? Greater than f of B. And if it has zero slope, what does that tell you then? They're equal to each other. F of A is equal to f of B. So by mathematical definition, here's what increasing is. If the y value of the first point is lower than the y value of the second point, the function is increasing, right? If the y value of the first point is higher than the y value of the second point, then the function is decreasing. If the y value of the first point is equal to the y value of the second point, then the function is constant. That's all it's saying, all right? Now, fortunately enough for us right now, when we start this, we're going to look at just a graph. We're going to look at the graph and tell whether it's increasing or decreasing or constant. All right? So, what we're interested in is this now. We're actually only interested in we want to know the intervals in which it's increasing, decreasing, and constant. And when I talk about these intervals, I'm talking about the domain. So what am I really talking about when I talk about the domain? What values? Say it again. X values. So I'm only interested in the X values. And in particular, here's what I'm really interested in. I don't care about the bounds of the X values. I don't care about the endpoints of the X values, alright? If you look at your graphs, you're going to see open and closed circles. Y'all see that? You're going to see open and closed circles in your graphs. I don't care about those bounds. Because I only care about the slope of what's happening in between those bounds, alright? And because I only care about the slope, here's what's going to happen. Remember, we say this, a function if it's open circle. What does open circle means? Not included. So that means you're going to exclude the function. And we use the parentheses to show exclusion, right? What does the closed circle mean? Include. And we use the brackets. Here's what's going to happen, though. When we start writing these intervals, the brackets and the parentheses, they're exactly the same thing here. These are exactly the same thing. Yes. So it doesn't matter which one you write with. You can either write it with these or you can write it with these, alright? I don't care about the bound. I don't care about the endpoints. Does that make sense? I only care about where it's increasing and what interval it's increasing. I don't care if you include it or not. I'm going to write mine with this one right here. Alright? So look at these examples. Let's take this one first. Example 1. And here's all I want you to do. I want you to tell me where's the function increasing at. So when we talk about increasing, we're looking for what kind of slope? Positive slope. We see positive slope right here. Does everybody understand that? Yes? So increasing the interval means you're looking at just the X values. Does everybody understand that? Where does it start increasing at? What X value? -2. And it goes up to what other X value? 0. Is it increasing anywhere else? By definition, again, this means that if it's actually increasing, then the first Y value, what's the Y value at -2?
0.
It should be less than the second Y value at 0. What's the Y value at 0? 4. 0, 4. Y'all see that? Is 0 less than 4? So is it increasing or decreasing on that interval then? Increasing. Because the first Y value is lower than the second Y value. Do you understand that? That's what increasing, decreasing really means. Now, where is the function decreasing at? Well, it's decreasing from what? 0 to 1 from here. And it's also decreasing from here to there because they both have negative slopes, right? So you're decreasing on two intervals here. You're decreasing from 0 to 1. That's the X values. You're also decreasing from 2 to 5. There's your other X values. And again, by definition, decreasing means that the first point is higher than the second point. So if you look here, you're going from 4 to 3. Here you're going from 1 to -2 on your Y values. So you're decreasing on the function, alright? Where's the function constant at? So, writing it the other way, -5 to -2, right? And constant means that from -5 to -2 is the exact same Y value. Is it the exact same Y value from -5 to -2? Yes, it's 0 there. You understand that concept? Alright, so what I want you to do is this. Try to do the next one, please. Find all intervals for increasing, decreasing, and constant. Label all your intervals. Alright, when we look at this, where does this function have positive slope at? Where is it increasing from? From 4 to, it looks like 6, actually. From 4 to 6? Is it increasing anywhere else? No. Where is the function decreasing at? So it's decreasing on this interval from 1 to 4. And it's also decreasing from 7 to infinity. Is the function constant anywhere? So -2 to 1. And again, you can check your X values and make sure. Check your Y values and make sure. from negative 2, 1, do we have the same y value? Yes. From 1 to 4, do we get a, does it drop in y value? So you start at 1 at 2 and it drops down to negative something, right? Negative 3. So yeah, you're dropping, so that means you're decreasing. Do you understand that concept? Alright. So now that we can find that, the other way we're going to classify these graphs, so that's classifying them by intervals. We're also going to classify them by what we call extrema. When you talk about extrema, what you're really talking about is your minimums and maximums. When I ask you to find the extreme of a graph, or the extreme is the plural form of extreme, I'm asking for maximum and minimums. If I ask you for a maximum or minimum, what would you tell me? How do you find the max or a min? What are you looking for? So you're looking for the highest point and the lowest point, right? So let me give you an example of a graph. And tell me what the max or min is of this graph, right? This function right here, what's the maximum or minimum of that graph? Can I be a negative infinity maximum now? Minimum, can I be a positive infinity maximum? Tell me what you just said. You told me it was the highest what? Keyword, you told me it was the highest what? No, you told me it was the highest. You said the highest point. That's exactly what y'all said. Y'all said the highest point on the graph, right? Is there going to be a highest point on this graph? Is there going to be a lowest point on this graph, right? No, so can we say it's the highest point and lowest point on the graph? No, let's try to find another definition, all right? Let's generate another graph. It looks like this. Does this graph have a max or a min?
Yes.
Good. Why does it have a max? It has the highest point on the graph, right? Does it have a minimum? No. Just write another graph. What does this graph have? Both what? Max and a min? But it's not the, is this the lowest point on the graph? Is there a point lower? Is there points lower than that on the graph? Yeah, there's plenty of points lower than that. There's actually an infinite amount of points lower than that, right? Is this the highest point on the graph? No. There's actually an infinite amount of points that are higher than it, right? But they are max and mins. Why? Let's formally define a max or a min now. What makes something a maximum? Is it the highest point? This right here is a maximum. I want you to realize that. That's a max. But it's not the highest point, right? What makes it a max? This right here is a minimum, right? But it's not the lowest point. What makes it a min? Good. He said it. When you're looking at this graph, what's happening on this graph? Let's talk about this. This is a max. Let's talk about this. What's happening to the graph? The graph starts to increase, and it hits this point, and what happens automatically? Starts to decrease, right? This graph starts to decrease. It hits this point, and it does what? Increase. It's increasing, hits this point, and starts to do what? Decreasing. This graph right here, it's always what? Increasing. What makes something a max or a min value then? What has to happen to get that value? It has to have some kind of change in direction. You have to change your direction. You understand that? A maximum value means this. In a max, the graph goes from, here's what happens. So your max, the graph is increasing, right? That's positive slope. It hits the max value, then what does it do? Changes to negative slope. So your graph goes from increasing to decreasing in a max. That's the definition of a max. It's not just the highest point. It's the actual point where the graph switches from increasing to decreasing. You have to have a change in direction to get a max. The minimum What do you think that is? Good. The graph goes from in order to get a max or a min, though, you have to have a change in direction. Do you understand that? Yes? It's not just the highest point, it's the actual change in direction, alright? So when we write that, here's what's going to happen now. We're going to talk about two types of graphs we're going to deal with. We're going to have what's called an unbounded graph and a bounded graph. Unbounded graphs look like this. Bounded graphs look like this. Both these graphs have minimums, right? Yes or no? Why? They have change in their directions, right? This graph goes from, it's decreasing, hits this point right here, and then what happens to it? It starts to, this graph goes like this, it's decreasing, hits this point, and what does it start to do? Increase. So they both have minimums, right? Everybody understand that? Now, do they, when we talk about a unbounded versus a bounded graph, here's what I'm interested in knowing. Here's another example of a unbounded graph. We just saw this right here, right? This graph has a minimum and a maximum, right? But here's my question. Look at this. Is this graph, this is the lowest point on this graph right here? Will any point ever be lower than this point? No. What about on this graph? Is this the lowest point on this graph? No. There's plenty of points that are lower than it, right? Just like this one has plenty of points that are higher than it. Does that make sense? When you have unbounded graphs, you will never have an absolute value in the direction of the arrows. Does that make sense? So notice this, we can never get an absolute max. We can never get an absolute max or an absolute min here. Does everybody understand that? When you have a bounded graph, though, you will always have some kind of absolute value. Or you can get an absolute value. So what that becomes is this, and we start talking about these. We're going to talk about what's called a local max. And local just means this. It's the highest or lowest, depending on what you're talking about. In a particular area. And when I say highest or lowest, I really mean it's the, let's change this to high, let's change this to maximum or minimum value in a particular area. So it's really the max or the min in a particular area. The absolute max or min is the max or min of the entire graph. That means it is the true lowest point. I mean, it is the true lowest point if it's the minimum, or the true the highest point if it's the maximum. Every time you write a max or a min, you're going to write it as this, a point. So point x, y. That's a max or a min. The x value is where the max or min occurs. The y value is the extreme value. That is the extreme value, and here's what that means. Real life example. You throw a ball into the air, right? Come back in 10 minutes, man. Come back in 10 minutes, man. Come back in 10 minutes.
No, I gotta go. That's it.
This guy right here. Alright. You throw a ball into the air. Here's what happens, alright? Throw a ball in the air, what happens? So it has to come back where?
To the ground.
To the ground, right? Here's what happens. Here's how it looks then. Throw a ball up. It's a certain point, and it comes back down, right? What shape is that? A parabola, right? What kind of value does it have? Does it have a max or a min? Max. It has actually an absolute max, right? There's no point higher than that. Does everybody understand that? The question becomes this then. You can ask two questions off of this. Where does the max occur? When does the max occur? Or where does it occur? That occurs at your x value. This is where it occurs. What is the actual max? Well, that occurs at the y value. So that's what when I ask you the question, when does the max occur, or where does the max occur? You give me the x value. Do you understand that? When I ask you what is the actual max or what is the actual min, you give me the y value, alright? So look at the graphs. On this, I want to identify all max and mins, and then label them as local or absolute. Again, we know a max and min only occurs when the graph changes direction, right? So you have max there, min, max, min. All the points where it changed direction there, right? This is a max. What's the value? At what point does the max occur? -4. What's the actual max value? 2. Now, on this graph, is it a local, also known as a relative? Is it a local or relative, or is it an absolute max? Is it the highest point on the graph, or is it just one of the higher points, one of the points on the graph? So this is a local max. Are there points higher than this point on the graph? Yes. Here, you have a point, -1, -2. Max or min? Is it local or absolute? Local. Why is it local? Is there a point lower than that value? Yes. Here you have is it a max or a min? Max. So you have a max occurring at 1, 0. Is it local or absolute? Local. Why is it local? Points higher than that, so this is a local max. Here, you have a minimum at 3, -1. Local or absolute? Local. Now, why are we getting all locals here? Because both these graphs, this is what kind of graph? It's an unbounded graph, right? There will always be a point that is higher or lower than these actual values. Does that make sense? Alright, so changes in direction, you have one occurring here, 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 and here. Your points are going to be, this one looks like it's at -2, something like that, -2, -1. Here it's at 1, 3. This one's at 2, -4, and this one's at 6, +8. At -2, -1, is it a max or a min? Min. Is it local or absolute? Local. So this is a local min. At 1, 3, is it a max or a min? Local or absolute? At 2, -4, is it local or absolute? It's local. Is it a max or a min? Min, so it's a local min. At 6, 8, is it a max or a min? Max. Is it absolute or local? This is absolute. It's the actual highest point on the graph, so everybody see that. Are these values out here going to be maxes and mins? Is this a max? Is this a min? Why is this not a max? Well, it's not because it's not the highest. It's not doing what it's not. It's not changing direction, right? Why is this not a min? It's also not changing direction. You understand that? Classifying max or min, you have to change direction to be a max or a min. Do you understand that? All right, man.